understand the problem number 1009. It's a complement of base 10 integer. So let's try to understand what we have given. The question is saying that we have given some value that is called n, and you have to return its complement. Let's suppose that you have given 5 as a n equal to 5, right? So if you convert this 5 into the binary, you will get some value. Let's suppose 101, right? You know the concept 8421, right? If you want the find a 5 into binary, you just need to do this 4 and this 1 become 5 and rest of the 0, right? So you can ignore this 0 for now, right? So if you have this data, right, that is binary number, if you convert this given 5 into binary, and if you will convert, if you take the complements, means all the zeros, all the zeros should be converted into 1 and all the ones should be converted into 0. It means, let's suppose if you convert this, so this 1 becomes 0, this 0 becomes 1, this 1 becomes 0 again. So you have converted this, right? You have converted this into binary, and from here you have flipped all the zeros into 1 while all ones into 0, right? Means converted and flipped, right? If you'll do that, you will get another binary number, right? This is also binary and this is also binary, right? Come back to here. If you'll convert again, right, then you will get how many number will become it? It become 2 only, right? So this is 001, so it become 2. So 2 will be our answer. You have to return, because this is actually becomes the complement. Okay, so if you're taking complement of any number, right, you have to return this data. This is what we have given. We'll try to understand what the things we have to do. The very first, that you have given a decimal number n, and our task is to convert the number into binary, and you have to flip every bit from all 0 into 1 and all 1 into 0. This is the thing you have to flip. Once you will flip all the number, right, you will get the binary again, because you have converted the new binary number back to decimal. You have to do, so once you do the back to the decimal, that's the final number is called complement. Okay, and that you have to return as a data. The most important thing we have here is the flipping, right? If you flip the bit that exists in the binary representation, so do not add extra leading zeros. Okay, this is a very simple thing we have to do here, guys. Okay, so now let's think about how we are going to solve this problem, right? So we'll go bit by bit, right, and we'll scan the thing, right, from left to right to left, we can say. Okay, let's suppose that we have given this 5, means this 5 we have given, and if you convert this, it become 101, correct? This is what we have given, n we have given, n equal to 5 we have given, correct? And if you convert it in the binary, you will get this one, right? Now we have to take a pointer that will move bit by bit in the process, right? So imagine if you scan the bit from right to left. Okay, so if this is your right and if this is your left, right, so we have to scan from right to left, we can say that. Okay, so right to left we have to scan. So let's suppose the very first thing we have given the binary. What is the binary we have given here? 101, correct? So step 1 we will do, we'll take the pointer to the last here, right? So pointer we have to take, let's say we will have a pointer. This pointer will contain the last bit. It will assign to the last bit, means this one. Then if we have already at 101, right, means we our pointer is here, means we have to flip this. So we'll say, okay, flip it into from 1 to 0, right? Similarly, in the step 2, what we will do, will once this is flip is done, means we have to say, okay, pointer, let's move, pointer will moves to uh, uh, left, we can say that, right? We'll move to the left. So what will happen now? 101, the pointer will come to here, correct? Now we'll say okay, flip again. So you will, from 0 it will flip to 1, correct? Similarly, we'll go to the step 3 and we'll say okay, pointer ptr move left again, right? So we'll say okay, now we will reach to 101 at this one, so we have to flip it again, so it will convert it to 0. So if you see the flipping things, we have 0, 1 and 0. So all these three we have to collect as a final data, right? So if you collect all of these, you will get 0, 1, 0. So this is what we will convert into, and we know how to convert this into the binary. Sorry, from binary to decimal. The intuition is very simple, that the complement means invert every bit, right? All ones into 0 and 0 into ones. But we must only flip the bits within the length of the number. So we have took very first the n equal to 5, right? And we will keep moving ahead, right? So there is very simple thing that we must only flip within the length of the number. Okay, so what we need to do, let's suppose, what I'm trying to say, if we have 101, right? If we have 5 and 5 is 101, so if we'll take the mask will take, and we'll say 111, right? So what will happen when you take the JOR between these two, means 101 will say, and we'll say okay JOR, and then we'll say 111, right? You automatically you will get 010, right? So these things we should do rather than doing everything here, right? So we create a mask of all ones, right? What we are trying to do, we will create mask of all ones, we can say. So that we need to do. Okay, so within the number of bits it will get converted. Okay, this approach we should do, and let's go to the board and the editor, and we'll do there. Before going to the code, right, let's understand some more thing, like how we'll do the optimal approach. How will you approach, right? Till here we have seen that we can do the JOR and we can convert that, right? So if we'll do the optimal approach here, let's suppose the bit mask, right? So bit mask approach we'll do. In that approach, very first what we need to do is we should find the number of bits. If we find the number of bits in the given n, we can say, then if you know the number of bits, right, you can create the mask. So you will do okay, create mask. How will create the mask, guys? You can do simply mask is nothing but 2 to the power bits, we can say, right? Bits and minus 1. Let's suppose, as example, we have given n is equal to 5, right? For example, we are saying n equal to 5, and how many bits we have here? We saw that 101 is there, so total bits is nothing but 3. So very first step 1, you found the bits, that is 3. Now you need to find the mask. So how will you find the mask? Just you say the n you will take and the mask, right? Simple. So if you take the mask of this 3, right, what you will get here? You will get triple 1, because the mask you have to is what? Triple 1, which is coming as a 7. So once this is done, in the third step what you need to do, you will take the JOR with mask. And JOR with the mask, you have already taken the mask, right? And this is the mask we have here. So we'll say okay, you need to do this step, right? So JOR with the mask is this step. Okay, guys. So you simply will say okay, JOR with the mask, you will do n mask this one. So this will be our answer. Okay, you can say step 3. And this is the mask is this one. Okay, give me 1 second. Better to clean again. Till here you understand, right? So you know that total bit is 3 here, right? So what is the mask here? Mask is 111, which is 7, right? Now in step 3, you need to do the job with mask. How will you do that? You will just say, okay, give me the result. Result is nothing but you take the jar and the mask, correct? If you do the jar with a mask, you will get the result. This is what we were going to do, guys. Okay, let's go to the code and we'll understand. So very first, what we need to do, we have to do find the number of bits, then you will create the mask, then you will do the jar and you will get the result. Okay, let's do. Okay, the very first thing that we have given int n, right? So if we'll say, okay, n is, if it n is equal to 0, just for the base condition, if n is 0 bits, what we need to do, we will return as a 1. Will not do anything, we'll return 1, because we have to flip all these bits into 0 to 1. Once you convert this, you know that what we need to do, the decimal you will return from 1 of the binary, you will get as a 1, right? After that, very first you will find the what is mask. So mask will say, okay, 0. Then you need to create a temp value, let's call int temp, and store your value, that is n. We will not directly manipulate over this n because we can lost this value, right? We need that n in the for the last step, right? Because we know that before returning in the last step, what we need to do, we need to do is n and the mask. We'll create the mask, okay? So we'll do the logic of this mask here. So this is the thing we need to do, right? So that is why we'll take the int temp and we'll store the n. Now the main thing is to, we have to create mask with all ones, right? How will you do that? While uh, temp is greater than 0, while temp is greater than 0, till that you will say, okay, mask is, we'll say the mask, and it should be left shift with 1, and you will get you will do or, right? We should do like this, yes, and 1, correct? So you will get the mask here, and then the temp should be the right shift with 1 we will do. So let me check here. We'll explain you what the code is doing here. Let's submit this. So as per the steps, we need to do these things only. Okay, today I have not submitted the code. Let's think that what is our code idea. Our code idea is to complement the given number. What is the given number we have here is n. We have to complement of a number, means we have to flip every bit. This is the thing we have to do, right? Means all bit means 1 will become 0 and 0 will become 1, right? That is why we have given here, for example, n we have given was 5. So if we convert into the binary, we'll get 101. And then we did the complement and you will get 010. Remember, this is the things we have given. But in Java, there is operator, right? Let's say this one, right? This operator flip all to 32 bit, right? Which gives the wrong result. So the trick is to create the mask of all ones, okay? And then with the same length as the number, we'll do the masking. And that is why, rather than not going that, we say n equal to 5 and we got is 101, and then we have done with the mask is 111. So if we do n XOR mask, right, you will get the result, because you know that one XOR, if we'll take is 1, will get 0, and 1 sorry 0 XOR, if we'll take 1, right, you will get still 1, right? So which gives you the perfectly flip bits that we wanted, right? This one. So that is why we should do the masking, right? And in the very first step, what we have done here is we have handled the edge cases. That is called if n is equal to 0 will return 1. Because see, if you'll take the binary, right? So binary of 0 is what? Is 0. So we have to flip it into 1. And the decimal of 1 is nothing but is 1, correct? So if the input is 0, right, you will get the value 1 only. Okay, so that is why we have to take as a base case. Then we have created these two variables, mask and n. Mask we have taken will store a triple one, right, with the same length here as n, and temp we have used to count the bit of n, right? Why we have taken, guys? Mask we have taken to store the triple one, right? And this temp we will use to count a number of bits, we can say, as simple. Sorry, guys. So we'll use this temp, right? So the original n is not changed, it remained unchanged. Okay, because we need at the last step we have to do the job with the n. So we will use this loop, right? We'll use this loop and we'll do the mask, right? We'll create the mask. How? We'll check if temp is greater than 0. We'll run the loop once per binary bit, right? And so we have, let's suppose we have n equal to 5 we have given, and binary we are getting 101, means this loop will run 3 times. Okay, and once it will run, this loop will run into 3 times, right? Because number of bits is 3. So left shift mask will happen here at the point of here, mask this left shift. So when we do, give me 1 second. Okay, so understand, when we do here this part mask, right? I'm talking about this part. When we'll do this mask, means the left shift mask, right? The left shift moves the bits left, right? So let's say the very first you have mask is initially you took 0. So the in step 1 you do very simple thing is shift with the 1, and it is equal to 0 like this. Okay, so what will happen, that you will convert the step in the very first loop. Now, because this is the first loop, so loop 1 will come run like this, loop 2 will run like this, and this is still 1, right? So this will become 1 0. Step 3 will run again because 3 bits is there, right? So we'll say okay, 1 1 and 1, and here it will become what is left shift, we can say, and this will become 1 1 0. Like this your left shift will moves, right? Because what the left shift is do here, right? The left shift moves bit left, right? This is what we need, right? So this, we know that this loop, right, for n equal to uh what we have is 5, right? We got the 3 bits. It means I'm saying if n equal to 5 we have 101 and we have total bit is 3, right? So this loop will run 3 times. 3 times this loop will work. One time when initially we will get the mask this, then you will get the mask like this. So you are seeing that each time the left shift is happening here. Okay, then you need to add the 1 here, correct? You are adding 1. So when you are doing add 1 to mask, it means what? We are doing mask, then 1. After this you will do adding 1. This part you are doing, right? It means if 0 is there, or if you're taking the 1, right, the OR operation, basically this is nothing but the operation, right? So you will get 1. If let's suppose 1 and 1 is there, right? Sorry, 1 and 1 is there. This is also 1, this is also 1. You will get 1. Means each operation adds 1 bit, right? Each operations adds 1 bit here, and so you are adding 1 to the mask, right? So this example is very important because you understand everything here. Let's understand further what is happening here, guys. Okay, let me explain how the temp is working here. Okay, let's think that. Come back again, n equal to 5 we have to write, and we don't know that the binary is nothing but is 101, correct? The initial thing that we have took is mask we have taken, so the mask is nothing but 0, and the temp will become is nothing but 5 because we have to store the same thing. Now in the iteration 1 we know that we have done the mask, so mask basically we want is 0 left shift and the 1 we can say, right? And with the or 1 means we have to add 1 bit. It means this time the mask is nothing but 1, correct? This part will give 0 and this part will we are going to add 1, right? So mask is 1. What is the temp now? So temp is 5 and we have to do the shift with the 1, so you will get the temp to here. If you do the binary view, right? So the binary view is nothing but mask is equal to 1, correct? So this is what we have here. In the iteration 2, when we'll do the same thing will happen here. We'll repeat the same thing. So we'll say okay, mask, which is now it converted into the 1, then you will take the left shift 1, and then we are taking adding 1 bit, right? 1 bit. It means you will get the result what mask is 3 here, correct? Means if you represent in the binary, right? So binary will become is 1 1, correct? It will become 2 1 1. Now what is the temp value is there? Temp will become 2 and we have to take shift with the 1, correct? Shift with the 1, then you will get what is nothing but 1 in that iteration 3. So the iteration 3 will happen where you will do the mask and mask, give me a second. This mask is nothing but 3 left shift will do and 1, and we will add 1 bit, so we'll get the mask 7 here, and that is the binary we have is 111, correct? It means we want temp now, which is we have to take 1 left shift with 1 and you will get here is 0. Now this loop will stop because on this thing will run only 3 times loop this one. So we got the bit 7 111 and temp is this one. So just you need to do what n and you will do the mask, right? So final thing is that it gives you the mask value is 7 and this binary is nothing but 111 like this, which perfectly matches the binary length of the n binary things, right? And it gives you the result, right? Now once you do the this part means you need to do something flip bits using the JOR bit, right? So let's suppose that n is nothing but is 101 and 7 mask is 7, the mask is 7, right? And that is nothing but what is 111, right? If we'll do the JOR, right? If we'll do the JOR operations here, we'll go 110, this one 01 is 1 and 11 is 0, so you got this result. So you have to convert into the value, you will return 2. This is our final answer, guys. Okay, so that's all I have in this video. In case you're struggling with anything, let me know in the comment section. And for the time complexity, guys, what will happen? O log n will happen, O log n, because we process each bit of n, right? And that is why we get O log n. So we don't have any extra spaces, so only few variables we have used, so it will take off one as a space. Okay, so that's all I have in this video. In case you are struggling with anything, please let me know in the comment section. Thank you
guys, thank you for watching this video. If you found this video helpful, please like, subscribe, and let us know what you want to learn next in the comment below. And thank you for watching this video.